Northrop Grumman supports the United States Air Force A-10 Aircraft Structural Integrity Program. Designed around the close air support mission, the A-10, also known as the Warthog, is critical to providing support to American and Allied soldiers and Marines on the ground, as well as to destroying a wide array of enemy targets. The A-10 was originally produced in the 1970s and 80s. The A-10 Aircraft Structural Integrity Program, ASIP, ensures that the aircraft structure will remain safe and serviceable to keep the Warthog in the fight for years to come. The ASIP program began with testing at Fairchild Republic Company at Wright-Patterson Air Force Base to validate the original planned service life. With the mission requirement to extend the service life through 2030 and beyond, the OEM team at Northrop Grumman in Bethpage, New York and St. Augustine, Florida, together with the Air Force and industry team members, has undertaken a variety of measures to ensure structural integrity and mission availability. Fatigue testing of the wing was performed in 2003-2004 to identify areas requiring reinforcement and to validate crack prediction methods and inspection requirements. The wing was placed in a fixture and loaded, using hydraulic jacks to replicate the spectrum of stresses representative of the A-10 aircraft maneuvers in the post-Desert Storm timeframe, 1992 to 1999. Load cycles were applied, representing equivalent flight hours of severe usage. Marker band loads were also applied for the purpose of identifying the point in time at which damage occurs. Fatigue testing of the fuselage and empennage are presently underway at the Northrop Grumman Structural Test Facility in El Segundo, California. This test is similar to the wing test in that hydraulic jacks are used to load the aircraft structure, simulating the loads experienced in actual flight maneuvers. These loads include gunfire loads applied at 60 Hertz, the first time such a test has ever been performed. As of March 2008, the test has accrued a large proportion of equivalent flight hours of severe usage toward meeting the Air Force's extended life goal. The loading and cycling of the test procedure is carefully planned so as to validate an extended structural service life goal, including a scatter factor of 2. At the completion of the test, a destructive teardown inspection is conducted to closely examine damage to the structure so as to proactively design repairs, reinforcements, and inspections if necessary to preclude structural failure. This teardown inspection process includes sophisticated mag particle and dye penetrant inspection of fastener holes, in situ, as well as microscopic fractographic analysis of fracture faces. Testing is used as a means of validating the crack growth prediction analysis performed by Northrop Grumman. A variety of analysis methods are used to determine the expected life of a piece of structure. First, the maneuver spectrum is analyzed based on the loads recorded during actual aircraft usage. Finite element models are used to simulate load paths through the material. Static stress and damage tolerance analyses are performed to determine adequacy of strength and resilience. In areas where a need is indicated, structural reinforcements are designed so as to modify aircraft before cracking occurs. Northrop Grumman is also developing new inspection techniques to minimize downtime. This patented infrared inspection system uses heat absorption characteristics of material to detect corrosion without the need to strip paint. Northrop Grumman is also investigating ways to reduce corrosion using new materials and coatings. New structural repair methods are being evaluated and tested to improve downtime and increase strength. Using a combination of flight recorder information and base-supplied flight logs, the individual aircraft tracking program calculates damage predictions for each individual jet based on the actual flight usage of the aircraft, including any component swaps or modifications that have been performed. This allows inspection times to be tailored to optimize aircraft availability. The focus at all times is to keep iron on the ramp, safely and effectively, to support the mission. As a key member of the overall A-10 Air Force and industry team, the OEM team at Northrop Grumman continues to provide support, analysis, and development to ensure that the Warthog is the close in close air support for many years to come.